to make sure that we're able to kind of get to all the questions and I don't actually miss things while I'm talking. But one thing I will mention is if you're having any sort of like technical issues, if something isn't actually showing, I think I'm sharing my screen, but I'm not. I'm very guilty of that often. Just put it in the chat and either I'll try to watch it, or Jesse, if at any point you want to interrupt me, that's to let me know something isn't working out right, that would be great. So I live in an ambulance route, so this is going to happen throughout the entire talk. Okay, so let me go ahead and start by sharing my screen. All right, so how to improve your workflow for reproducible science. That's today's agenda. And really another thing I could kind of say here is we often find ourselves in this situation where the results in table 1 don't seem to correspond to those in figure 2. And that's a lot of what we're going to go over today is basically trying to avoid this situation. So how might we go about doing this? Let's take a look at these random numbers. They are indeed random numbers, but they're random numbers you can regenerate yourself, because when I generated these random numbers, I actually set a seed and I'm sharing the seed with you, and I'm sharing the code I have to generate the random numbers with you. This is like very minimal reproducibility in the sense that if you have any sort of randomness to the work that you're doing, one great way of kind of making sure that you can still reproduce your results would be to set a seed and have a record of that. Now I'm going to throw out a few more numbers to you though. The number 70, more than 70% of scientists who were surveyed as part of this Nature News article, the 1,500 scientists said they have tried and failed to reproduce another scientist's experiments. And another number 50 said that more than 50% have tried and failed to reproduce their own experiments. That's a pretty striking number. Now, I want to be clear here. When they say reproduce their experiments, sometimes what they might be talking about is exactly what we'll be talking about today, the computational reproducibility. But obviously, there are other reasons why you may not be able to reproduce your results from your experiment that might be domain specific to your work and how your experiment is set up. And that's not really what we're going to get to today. So these are stark numbers. Not all of these scientists who said that they have failed would necessarily be remedied, their workflow, by what we're going through today, but I bet many of them would be. And here's another number. I did a Google Scholar search yesterday, and that was since the beginning of 2020, the term reproducibility crisis appeared 1,010 times in published articles in this year. This is another striking number, but I also want to be a little bit honest here. There's potentially a little bit of a publication bias, because if you have striking things you're saying in your paper, maybe it's more likely to be biased. So reproducibility crisis sounds a little bit more perhaps striking than reproducibility issues or improving your reproducibility. So maybe some of these things are getting published because of the terminology they use. But I think we can all agree that there is an issue with reproducibility for many axes of that, and computational reproducibility being one of them. So I want to start by setting the stage here. There are really two types of reproducibility we could be talking about. And in my mind, I kind of distinguish these as replicability and reproducibility. In both of the cases, we have the same research question we're working with. We want to get the same results. That's our goal. But in the case of replicability, what I often think about is that you're working with new data. You've observed some results from a study that you've worked on, and now you have new data and you want to see if the results you've previously observed actually holds. You maybe have a new population or another researcher is trying to reproduce your work. Give me 1 second. I should have closed it earlier. Versus in the side of reproducibility, we're working with the same data. You're literally trying to reproduce the same results that you have arrived at before, or your collaborator has arrived at before. And the goal is that you actually manage to do so. this is the type of reproducibility that we are going to be talking about today. But if you're more interested, or if you're also interested in this idea of replicability, there's a lot of great work to read out there. I'm going to cite one short paper here, which is the American Statistical Association statement on p-values. And this is not necessarily to start a discussion on p-values per se, but they have very good references. So I thought it would be a good one to reference quickly in a talk, because they touch on a lot of good references on this issue of scientific replicability. But today our focus is going to be on computational reproducibility. So what do I mean by that? So let's take a look at this. I have a regression output in my table, 1, okay, and this is what things look like. And then later on in my manuscript, I have a figure that also shows the relationship between the same two variables that we're looking at, that the table was about. I'm using the Palmer penguins data set here, where we have 3 species of penguins, but we're only looking at 2 of these. And let's say that this is my table 1 and my figure 2 from my paper. Well, there is an issue here. I have a negative slope, but in my figure, I'm seeing a positive slope. How does this happen? You might be thinking it's just carelessness on your part, and that is probably true, but I think the reality is that it's very human carelessness. So one way this happens is you start writing your report, and then you fit a model, you copy and paste your model output into your report, and then you carry on, and then you do a little bit more writing, and then you say, okay, maybe this would be a good time to supplement my work with some visualization. And then you create this visualization as well. And you observe that of these 3 species of penguins, one of them is not like the other 2. So maybe you decide at this point, perhaps I need to be doing some sort of subgroup analysis. Maybe there's a reason why those penguins in the bottom corner, the Gen 2 penguins, should be analyzed separately, and decide that that's no longer a focus of what you are writing on. And then you go ahead and remake your plot and say, I think that looks like a better relationship for me to explore. And if you just simply stop here, you're basically left with what we had at the beginning, that you have this workflow that is copy and paste based, and you as the human needed to remember to go back and update your earlier results as well. And in a realistic situation, chances are, 1, the model you're working with is a lot more complex, and number 2, you're probably looking through a lot more pages. So these are not just 2 numbers that are so apparent and highlighted on a single page. When this happens and your data changes ever so slightly, or in a big way like this, it's you, the human, who needs to remember to go back and redo your earlier results. And if you have a workflow that is based on copying and pasting statistical output from software into whatever document you're working in, Word, Google Doc, whatever, it is possible that you're actually going to forget to make that change, especially if this is a collaborative project and you don't have a good collaborative workflow either for tracking changes by other people. This is even more likely to happen. So seems like a careless mistake, but one could imagine this sort of thing happening all the time, and it does actually happen all the time. So what we want to work through today is, how do we try to avoid this? And if I was to tell you that, well, you should just be more careful while doing your work, that would be one way of avoiding it, but I don't think that's actually helpful advice. So what really we want to do is, how can you use tooling that would never allow you to find yourself in that place in the first place? So if you want to make your research available and accessible, really the things that you need to think about is, how do you make your raw data available and accessible? How do you make your code and documentation to reproduce your analysis available and accessible? And also the specifications of your computational environment. Today, we're going to focus a lot on code and documentation, but I want to be honest from the beginning that sometimes even that is not enough, because even if you have meticulously commented your code and have actually distributed your code along with your research, if there is a possibility others will not be able to reproduce your results exactly if they're not in the same computational environment. This probably depends on exactly what type of work you're doing. But this is another thing that we kind of need to talk about. And while I won't spend a whole lot of time today about the computational environment, how to share your computational environment, I'll make a few comments about it before we wrap up the workshop today. So here's a quote from Keith Baggerly, who is at MD Anderson in the US, and he is famous for kind of cracking one of these reproducibility case studies on a cancer research study. And in his quote, he said, "The most important tool is the mindset when starting that the end product will be reproducible." So what do I mean by mindset? If this is our reproducibility spectrum, and on one hand, you have nobody, not even yourself, can recreate any part of your analysis. And on the other hand, you have push button reproducibility in your published work. Like somebody else can come find your paper and click a button and actually reproduce all of your results. You kind of want to be over here, right? But honestly, the closer you can get to that point is better. So we will be throwing a lot of tools at you, but it is possible that you might find yourself in a situation where maybe doing all of this at once is not feasible for you. My mantra for trying to get my work to be more reproducible is, with each new project, can I push myself a step further in this spectrum, as opposed to trying to hit the target from the very beginning. This might be because of your time. This might be because of technical knowledge that you need to have in order to be able to do better. And sometimes it might be because of resistance from collaborators as well. So there's really no one-size-fits-all solution for computational reproducibility. So some of what we talked through today may not necessarily apply exactly to your work. Hopefully during the Q&A, we'll be able to address some of the things that may not work, as well as some of the demos I'll go through might. But ultimately, I think that there'll be a lot that you can borrow from here. But the following that I'm going to talk about might help. And I'm going to talk about 8 principles for reproducibility. The first one is your project organization. So again, let's think of this level of organization spectrum, where on one end, this is what your project looks like. And on the entire other end, you have the Marie Kondo, everything in its right place situation. You kind of want to be on the higher end of the spectrum. So how might we think about getting to that point? Your folder structure is an incredibly simple but also effective way of organizing your work. Think of every single project you're working in as its own folder, where project work is scoped within that folder and doesn't tend to reach out regularly from that folder. And maybe you have something like this. If it's a simpler analysis, you have a folder called raw data, where you put your raw data, the holy data that you don't get to touch ever. And then you read that in whatever software you're using. So I'm going to give R-based examples here. So thinking about using an R Markdown document to do your data processing. And then perhaps you save the results of that process data. You save your process data in another folder. So that's basically where your analysis of your data starts with. And then you have another folder called manuscript that contains an R Markdown document. A more complex analysis may need a little bit more thought than that. Perhaps you don't want your analysis to be structured in a way where every time you knit your document, you're rerunning your entire code, especially if you work on computationally intensive stuff that may not be very feasible for you. So in addition to your raw and process data and your manuscript folder, you might have other scripts that you run in a particular order, and maybe even a folder for figures that your manuscript source code pulls in. Importantly, you should stick with the conventions of your peers. And if you don't have conventions among collaborators, this is a good time to, at the beginning of the project, or wherever you are in a current project you are, is to stop for a second and think about what sort of folder structure are we using? Because if your workflow depends on collaborators emailing each other Word documents, but there's no parity between how you're organizing your files between the collaborators, inevitably that workflow is going to break at some point, because people are potentially thinking about how they organize their work slightly differently within the small group of collaborators that you're working with. Number 2, write readmes liberally. So we talked about this raw data file, for example, and let's say that you have a bunch of data CSV files in here. put a README in there that has some useful information, something that has information on the data provenance and some information on what every single data file contains. This will stop your and others' urge from double clicking on those files to open them up, because remember, we don't want to be touching our raw data. Ideally, you're not opening those raw data files with a program like Excel, which might actually change some of your data types, even if you never intended to do so. And even if you never intended to do your data analysis there, and all you wanted to do was to just take a quick peek to see, I wonder what's in here. Keep your data tidy and machine readable. So let's give an example of this. And I'm going to give an example that comes up for me very regularly in my domain, which I teach a lot, and often keeping track of student records. And turns out it's actually very difficult to keep track of student records reproducibly, because the learning management systems make it a hell for you to try to do that. So they will spit out some sort of a data file for you. So let's say that this is what I have as my data file. I have each row is a student, I have their exam grades, and I also happen to know their majors. And then I also have some notes to myself. Gabrielle, for example, I don't know her major. One person was sick for exam 2, one person missed exam 1. So I have this sort of information. And also perhaps for me, I have highlighted some of the students that have low participation. So when I look at this data file, I get a sense of who they are and what I need to keep track of. Unfortunately, while this might be very easy to consume as a human, for a machine, this is not really readable. So our machine readable version of this data file would look something like this. And going from the human readable version to the machine readable version, which is still human readable as well, so you haven't lost anything, you want to record your code and document any sort of non-code steps if you had to take. Sometimes you do need to get rid of those colors, for example, and write some tests to make sure that as you went from one version of your data to the other, something unexpected didn't happen. A very, simple test might be, is the number of rows in my input document the same as the number of rows in my output data file, for example? So what we've done here is we've added a new column for the participation level. So it's no longer using color to indicate that variable. And we've also expanded that major variable to make it a little bit easier to consume. Number 4 is to comment your code. So here is that same diagram I showed you before from figure 2. And I have this time, instead of fitting a linear model, fit a smooth curve to it. But look at my code. And I have some comments in my code, right? It says uses lowest smoothing, but I have a span parameter in my code, 0.375. Why did I decide that? So commenting your code is not just about what your code is doing. In fact, that's probably the least useful thing you can comment your code with, especially if you are not doing something, entirely eccentric with your code. If you have some like crazy regular expressions in your code and you figured it out somehow, but that next time you look at it, you'll have no idea what you did there, then obviously you should explain what you did. But more importantly, explain why you did something as well. So any sort of parameter specification like this should be noted to say, why did you land on that number? And that will be useful not only for a collaborator you might be working with or somebody else trying to reproduce your work, but honestly you as well, because in 2 months' time, you'll have no memory of why you picked that number. And number 5 is use literate programming. So what do I mean by literate programming? I mean something like this, where we basically have an R Markdown document, right? And I'll demo this for you in a second, but you can basically see that my code and my narrative are in one place. So an R Markdown document looks something like this, where I have some information called the YAML on top. That's metadata about my document. And then I have my narrative and then my code all in one place. And I just click on knit. and I actually get the rendered document out. So instead of that copy and paste paradigm we talked about earlier, we want to be living in a space where we're actually doing our work using literate programming. And so now what I'll do is I'll switch away from the keynote slides and share my screen with you so we can actually develop something like that, our Markdown document. Okay. All right. So here is my RStudio window, and I want to start by saying something that, well, actually, let me just go ahead and start with things, and then I'll tell you a little bit about the version. So we're going to be using R as our computing language, but we're also going to be using RStudio here, okay? What I am going to do to start with is I'm going to start a new project in my RStudio window, and I'll create a new directory, a new project. Let's just call this demo, and I'll just put this on my desktop for now, and let's create the project. Are you seeing these double cursors? Okay, let's just make it. All right, and is the font size and whatnot good here? Yeah, okay. Let's make this a little bit bigger. So what I'm going to do next is to create our Markdown document. Maybe let's call this table 1 matches figure 2. All right, and let's go ahead and knit this document. And let's quickly take a look at the output. So I'll say a few words and then I'm going to switch to a new view. We can see that information we have in our YAML, which is our metadata about our document, has been rendered nicely to be kind of the title and the author name and the date that, that we're doing this. We can see that there is a code chunk here that doesn't actually show up in our document because it has an option that basically allows it to hide itself, and I'll say a little bit more about that in a second. We have some narrative that's been rendered nicely. So this is using Markdown rendering for the narrative. And importantly, we have some R code in our document that when we knit the document, we actually get to see the result of our R code as well, okay? So now what I'm going to do is I'm going to spend more time with this R Markdown document for this demo, but I want to demo something new for you, which is the new visual editor in the RStudio IDE. And that's what we're actually going to use. So if you have used our Markdown before, you were probably very used to the look that we had earlier. If you are just starting to use our Markdown, or if you have been using it for a while and you're looking for like a new way of authoring, I would very strongly recommend the visual editor, and I'll give a few plugs for why I think that might help with your workflow. Beyond just being kind of visually pleasing, to be honest. So the RStudio IDE, and you can get to this in the preview version of RStudio. So if you go to download RStudio, but instead of downloading the official release, if you download the preview, which I will say is pretty reliable. You know, it's not really the daily test version of RStudio, but the preview, you'll be able to get a hold of the visual editor. And the way I switched between the regular R Markdown and the visual editor is simply this button here that says switch, that allows you to toggle between source editor, which is the kind of the standard version of R Markdown you might be familiar with, and the visual editor. So let's do a few things here, okay? What are some things that you might be able to do? So I am going to start by setting up my kind of the packages that I'm going to use. So I'm actually going to go ahead and kind of delete a few things here so we can start from scratch. This original document is nice, but it has a lot of bells and whistles that you might not need. So I'm going to start by inserting an R chunk. And the way you can do that is you can basically do / which will open up this kind of widget for you to insert, you know, whatever you like. In this case, we want to insert an R chunk. And I'll add a few packages here. So one of the things you can see that I've done here is my packages. I haven't just loaded my packages, but I have some comments next to it that basically tell me what I'm using the packages for. And I find that to be very useful because sometimes I change my mind about my analysis downstream, and then I might still leave these library functions up on top of my document, and I might just be using unnecessary packages for my document at that time. So it allows me to not do that. So, and another thing that I like to do, I don't think this necessarily has anything to do with reproducibility, but whenever I'm loading my packages, I try to load them in put them in alphabetical orders. If you have a long list of these things, it's kind of helpful to try to see what's happening. So let's say that now we're going to do a little bit of writing. In this report, we evaluate the relationships between body measurements of penguins. The data come from, and I'm not sure if you're familiar with this, but there is a package called Palmer Penguins that we're going to be using here. So let me go ahead and bring this up. So let's say that this is the Palmer Penguins package that I'm going to use for my data, okay? There is a link here that says, how do I cite Palmer Penguins? And it actually has some information about the package itself. And then another thing that we have, so we have a DOI here for the package. We also have some information on the original paper where the data was as well, okay? So let's go ahead and say that I actually want to cite this paper. So what might be one way that I do that? What I'm going to do is I'm going to copy the DOI of this paper, and then I'm going to say that I want to add a command citation, which you can actually bring in something from a DOI. So you can actually tie in your reference management into this as well. So you can look it up with a DOI, and at the end of the demo, I'll link to a few more things written up about using the visual editor and citations, where you can link this up to other bibliographies or a Zenodo as well, if you're a Zenodo user, for example. So here it is, and I'm going to go ahead, and I want to use in-text citation for this. So I'm going to go ahead and do that and insert it. You can see that a few things have happened. In my YAML, I now have a bibliography added. And if I go to my files, I now have a references.bib added as well. And that basically, that file actually has the citation for that paper. So I didn't have to go ahead and search for this or figure out how to format my references. Let's say this, and I'm going to go ahead and knit the document. And we can actually see that we have a bunch of stuff which we'll talk about in a second, but you can see that in the text I have in this report, we evaluate the relationships between body measurements of penguins, the data come from, and my citation is actually there. And you can see that I actually have my references listed here as well. So I probably want to do something like a heading where I say references. So those are actually separated away. So let's go ahead and do that. So that looks a little bit more like what we might want. But what's happening on top? The tidyverse package especially tends to be very chatty. And when you load it, it gives you some information about what it's doing because it actually loads 8 packages at once. So we get this message that it prints out that's helpful for the user to know because you get to see which versions of the packages it brings along with it. But that's certainly not something that I would want on my output. So what I then get to do is add some chunk options. So there are a few chunk options. There are actually many chunk options, but ones that you will probably find yourself using commonly are message, warning, and echo. So what message does is basically it hides away any of these R messages. I tend to not set these on by default, but once you've seen the message and you're like, okay, I get what it says, and I certainly don't need that on my output, I can hide that away. Now, another thing I can do is if I'm actually preparing this as a manuscript, I probably don't want my code to be shown at all. So I can actually say echo false, which will still run that code chunk, but will not actually show it to me. So now things are looking more like what I might want them to look for a manuscript that I might submit somewhere, right? Okay. Now we have our references here. We talked about references. Let's talk about a few other things. How about we insert an image, for example? So let's go ahead. We said that we're going to look at some body measurements. So we can actually very easily insert an image as well. There's a nice image on the Palmer Penguins package website over here that actually tells us what some of these body measurements are. So what I'm going to do is I'm going to copy the address of this image and simply plop it on here. I can add a caption. I can also add a tooltip, which means if I hover on it, that's the text that it's going to show me. And I probably might want to add a link to it to the package web page as well, since that's where it came from. So I can kind of see here's my image. I can do things like make it smaller. I could do other things as well, so I'll show you very quickly. If you know a little bit of CSS and you want to format it a little bit differently, that's the sort of thing you can add here. But I'm gonna let go of that for now, and let's go ahead and knit this document. So this is we're not at the R code stage so much yet, but we've at least added an image to our document using this. Now, the nice thing here is that even though we're using this visual editor, we're going to see in a little bit that all of this under the hood is actually saved as plain text. So when we talk in a little bit about version control and check this file into Git, you'll be able to see what the document looks like under the hood, okay? In fact, we can go ahead and switch. So this is really what the document looks like under the hood. But if I switch back to the visual editor, this is what I get to see it as I'm working on it. All right, so let's go ahead and say, remember that we had actually talked about maybe eliminating some of the penguins or something. So let's talk a little bit about inline code. So I'll create a code chunk first, an R code chunk, where I say penguins and filter out the Gentoo penguins. So I'll do something like this, just so I have this here. And so one thing I can do is I can knit this document to run my code, but you're going to see, let's go ahead and let it knit for a second. So right now the code is there, but I have nothing in my environment. So your R Markdown environment and your global environment are entirely separate from each other. And that's by design. This is not an oversight. And that's by design because we want your document, your computational document, to be entirely reproducible and not reach into your global environment and do anything there. But the reality is, when you're working on a document like this, sometimes you just want to see in the console what's happening, right? So one thing that you might want to do is run your current chunk in the console. So I tried to run the current chunk in the console and I'm getting an error. And the error basically says that object penguins is not found. Why is it telling me that? Because I never loaded the package in my environment. So another button that you have in our Markdown is this one next to the green arrow. That's like a down arrow that says run all chunks above. So at any point where you are kind of breaking the chain of reproducibility and not running everything up to that point, this is a handy tool for getting everything up to that point running in your console, so that you can then run that as well. So now I actually have something in my global environment. Our Markdown is not going to reach in there and use it, but it allows you to kind of interactively take a look at this data file that you have, maybe do some quick calculation that you may not be interested in putting in your R Markdown document. So now let's say a couple words about inline code. So one thing that you might want to do is say something like the original data set has so many observations, let's say, right? So I could actually take a look at the penguins data set and note that there are 344 observations, and I could say something like, do something like this and put that number in there. But again, that's not going to be reproducible. So any number that you're hand typing, you want to try to avoid. Then how can we avoid this? We can use inline code for this and say, so I did a backtick and then R, and then using the nrow function to get the number of the rows, and I can see the code in my source, but in my output, I can actually see that number, and it's going to be, not only can I see that number, but you can see that it's styled exactly the same way as the text around it, which is really neat, because even if you have that sort of thing in a header, for example, it's going to be styled in exactly the same way. So you are getting to use inline code to generate these numbers, but on the output, it looks like just like the rest of the text around it. Now, this is simple, but we can actually do a little bit more than this. We could say from maybe, let's say, so many species, and then we can put the species names in here, right? So in the original data set, we had 3 species. So something, instead of me typing that number in, the number 3, here we go. I could do something like get the species column and then get the number of unique observations and get the length of that. So that should get me the number 3. There may be a simpler way of doing that as well, but that's kind of what I was thinking on the fly here. And now I'd like to show you, so that's just basically what we did, but showcasing that you can do longer code chunks as well. I have to say, sometimes this sort of look ends up being a little bit hard to read. So something that I like to do when I'm writing this much code in line is actually to take this sort of code and put it into a code chunk where this is initially calculated. And maybe then I can even get to comment on it. And then I can simply call that here. So you should think about not putting extensive code in your inline code chunks, because then it's just kind of wrapped around lines and lines and becomes a little bit hard to debug and definitely hard to test for. So you can imagine if I was to also then turn off this code chunk, we wouldn't be seeing this, and then we would only be seeing the text. Now, I want to show you one other thing here, and that's going to be how do we write the names of the species? So we have three species here: Adelies, chinstraps, and gentoos. So that's a text string that we want to construct. Okay, you can also construct text strings in your our Markdown document as well. So let's give that a try. So names of species, for example. And what I'm going to do is I'm going to say that I want to take a look at the species column. I would probably do it something like this. And then ask for the unique observations in there. So here are the species, Adelie, Gentoo, and chinstrap. But the way I would like this phrased in my document is probably going to be Adelie, comma, Gentoo, comma, and chinstrap. And I use the Oxford comma as well, so I'll use that here. And a function that I can use for that is from the glue package called glue collapse. And so it takes the character, it's going to take these three elements in the vector, collapse them into a character string separated by comma and then a space. And then for the last one, though, I'm going to use the Oxford comma and an end. So if I actually run this, I can see that the character string that I create, oh, I need another space here. So let's try it again. The character string I create is actually something that I might want to use in my text. And then I can go ahead and plop that in as my R code. And let's go ahead and give that an int. All right, so we've done a bit of work here. So what I'd like to do now is take a little bit of time, maybe until 1/2 or so, to answer a few questions. Maybe we can then take like a 2 minutes, let's stretch our legs break, and then come back and continue working on the document, and then next do a demo for using Git as well. So I'll open the chat here. I think that I've been seeing some questions that are already answered, but I'll try to quickly scan through them. So the official version with the visual editor, I actually don't know officially a particular date, but I imagine it should be, I imagine if it's not in the year 2020, it would be very early 2021. So since the preview is out, I would imagine that the official version is coming soon as well. One of the things that I'll link to at the end of this bit talking about literate programming is some of the blog posts RStudio has had on the visual editor. And so I would watch there the RStudio blog for official information on a release date on that. Okay. Right, end of the year. So Zotero, it does work with, and there's just from yesterday, I believe, a blog post I'll link to that actually walks you through the Zotero integration for this. And you can also use your own bib file, of course. Yes. Let's see. Markdown and LaTeX, you absolutely can. So LaTeX works natively here, I believe. So let's go ahead and do this. So let's do this. So you can see that it actually also shows you inline what's happening. And if we go ahead and knit it, we should be able to see that in our output as well. There we go. Can you adapt the document formatting and reference formatting? So yes, you can adapt the document formatting and the reference formatting. So in a little bit, I'll show So I'll give a quick answer and then maybe we'll have time for a demo on that as well. One of the things, for example, I use regularly is an R package called articles. So it starts with the letter R and then tickles. And it has some built-in formats for certain journal styles. So the R journal, I know the ASA style is there, which is as a statistician where I tend to submit work to. I think PLOS is there, for example. So you can actually use one of those style files. But similarly, you can add any sort of LaTeX style file to your R Markdown documents. So it'll read in any sort of tech file. You add that in your YAML saying that this is the style file that I want for LaTeX. And so you can style it that way. That's for PDF output. Similarly, if you have HTML output, you can use CSS styles for it. Using large external database that might be shared across different projects. So I think there are a few pieces of advice for using large external databases. And I think that no one advice applies to all others because people have their database setups, slightly differently. Obviously, this approach of maybe pulling in things in your R Markdown document may not necessarily work for you, that you might be working with scripts first, so you're not necessarily pulling in from the database every time you knit, depending on what sort of data you're working with. But there are packages in R that are for kind of talking to databases. So I think what you would ultimately do is use a package like that. So, and then also there are packages in R for so you could be reading the data from your database with a package called like DBI, for example, but depending on what you're trying to do, you might actually be doing the computation in your database as well. So an example I'll give for that is, there's dplyr for data wrangling in tidyverse, but there's also dbplyr, which is doing dplyr things, but data that lives in a database. So sometimes the answer is, how do you get your data out of the database? But sometimes the answer is actually, can you not do that? And can you actually do the computation there and then obtain the results? What's the advice for using data you don't own and cannot share, where the documentation is publicly available, but not the data? So it depends on, I suppose, what you're doing with those data. I mean, if you have access to that data and your collaborators have access to that data, all of this ultimately works, right? But if the idea is, then how do you publicly share your work that's based off of that data, then I would imagine that you would set up some mock data that follows the same structure, just so you can walk others through your workflow. But I imagine in that question, you have access to that data. So I think everything that we're saying here would still work with that. So when using an R Markdown document, find it really slow to work with, need to run all chunks above when using big data sets, etc. I think there are a couple answers for when things are really slow. So one answer is that you can actually cache your results in R Markdown. So let's say that I am doing, some big computation here, right, in this code chunk. So I don't want it to run over and over again every time I reknit this document. What I can add here is an option called cache equals true, which basically will cache the result of that. So if I actually knit this document real quick, and let's take a look at the Files tab. You can see that we have a new folder here called the cache. So if you ever want to clear it, you could actually delete these things, but this actually has an R data file with the result of that chunk. So next time that I knit this document, that chunk will not run again unless I've actually changed the code in that chunk. And then it knows that obviously something changed that it needs to rerun. However, if you know this famous saying, oh, now I can't remember who to correctly attribute it to, so I apologize. But the quote is, there are two things that are difficult in computer science. One is cache invalidation and the other one is naming things. So working with cached results is a hard problem to begin with, and it's not perfectly solved in our Markdown either. So I will say that if you are caching your results, one, if anything is unexpected, go ahead and delete it. So you can actually just delete that folder like this, and that'll give you a fresh start. And another thing that you want to keep in mind is that our Markdown decides whether it should rerun that code chunk based on whether you actually change the code. So like you actually touch the text in there. But a reason why that code chunk might need to rerun is because if a data that was being used in that code chunk earlier on changed. So for example, that example I gave earlier on, where I subsetted my data to begin with, and I changed an earlier code chunk, if I didn't touch the text of the code chunk here, it wouldn't rerun it if it was cached. So you need to think about, do I need to rerun this chunk again if you're doing this sort of caching? Because it won't be able to catch those sorts of changes. That's one answer. The other answer is maybe a single R Markdown document is simply no good for you. And in which case, which I have had projects like this. So what I was suggesting in the organization slide was that maybe you would have a folder called scripts. I don't know why I call this scripts. I think probably many people like calling it R because maybe you'll have some .r files in there or something. And then you would have some source code here that actually does some of the more computationally heavy pieces of your work, and then writes the result as, for example, an RDS file that's saved in another folder here, that your R Markdown document then just pulls in. So you might be doing those computationally heavy things there, and then you would do something like your big result from those scripts was saved in an RDS file that you pull in, and then you do the computation based off of that. So that might be another way of kind of speeding up the work. Perhaps separating, I often use that in the context of separating data processing and analysis, for example. So there is an option to add comments. It's not necessarily the same as what Microsoft Word looks like, but you can actually add comments here. And what I like about it is that they're just HTML comments, as you can see. If you know a little bit of HTML, this will look familiar to you. But what I like about the visual editor is that this is going to be kind of highlighted in a different color, so it becomes really easy to see. It's also diffable, so we'll talk about tracking things with Git in a second. So in a Word document, you would have these comment boxes on the side, but in our Markdown, you don't really have that. But if you take a look at the differences between your version and your collaborator's version, these would be highlighted as differences. And you can see that because these are also not just verbal comments, but HTML comments, they actually don't show up in the rendered output. So collaborative work on the same R Markdown document with a colleague. The harder answer is using Git, but when you say you're thinking of something like Overleaf, I feel like maybe you're also thinking of something like Google Docs, in which case the answer is yes and no. So RStudio Pro has an option for doing this, which is RStudio Pro is, so not the open source IDE product, but one of the pro products that RStudio has, which if you are an academic and using it for teaching purposes, you can have for free, or I think if it's for research purposes, you can have for a reduced amount. I don't know the percentage, but some reduced amount. And that has collaborative editing. Otherwise, I think you would be, the method that we would recommend would be using Git, which we'll show in a little bit. So For advice for working with collaborators who are not familiar with R Markdown, I suppose would be, if it's simply a no-go, you can knit things to Word. So you can do this, and then actually, so you need to have Word installed on your computer, which I do have. I'm like a little bit nervous doing this because I never do it. So, you know, you never want to do something you don't do regularly. You do it. There we go. So you can actually do this as a Word file and take it out. So then you could take advantage of things like comments or track changes. I do know that there is some effort in the community, and especially I think the scientific art community, of like then trying to go back from here to R Markdown. So if your collaborator has made edits in the Word document, can we directly get them back into an R Markdown document? I personally don't know of a perfect solution for it. That doesn't mean it doesn't exist. So if others know, please do put that in the chat. But I know people think about that a lot. But I will say that, you know, if this is like some of your colleagues are simply not going to be using R Markdown, maybe this is the output you send them, and then you meticulously kind of transcribe their changes. What I am going to guess is that if somebody is choosing to edit the document in Word, what they're touching is mostly the words as opposed to the code and the output, in which case it is not so cumbersome to perhaps transcribe those kinds of changes if they've tracked them themselves. So inputting raw data. So we can definitely do that. So how about we do this? I think the best practice for reproducibility would be something like having a data folder, or if you have raw and processed data, you would probably want to separate them. So I have a data folder here, and let me go ahead and I will steal something from here. Where were we? Demo, data. And I'm actually going to put an Excel file in here, okay? And let's go ahead and add a new package. If you're going to read just a CSV file, you don't need to add another package. Tidyverse does that, but I figured I'll try an Excel file for reading in Excel data. So let's go ahead and why are you upset? Okay. Let's read some data in. I'll add an R chunk. I'll name it. I'll mention one other thing. It's very easy to get sloppy with not naming your R chunks. I am very guilty of it myself, but if you name them, you can jump between them really easily here. And also if there are errors in them, when you get the R Markdown error in your console, it tells you which chunk it's in, if it has a name as opposed to some random number of a chunk. So that's really handy. So let's say this was a data set called favorite foods. So I'm going to read this Excel file, and I'm doing, so what I'm doing here, and I should kind of talk through this. We're going to give the path of the file. So I'm currently clicking on the tab button on my computer to get to, so that it allows me to search for folders in that directory. And then since there's only one file in the data folder, it does that for me. I can, so it says could not find the function because I haven't actually loaded the Excel package in my console. But now you can see that I have read it in, and maybe let's do some calculation on that. And let's go ahead and knit this document. So this is what I would recommend. A text file, CSV file, each of these have different functions for reading them in. If you're reading from things like SPSS, data, whatnot, we're still knitting to Word. Anyway, you can see that it actually worked, that we were able to knit it to Word as well. We'll go back and change this to HTML for, oh, come on. the next one. If you're reading in data from other sources, there's probably a package for doing it. Haven is a good package for reading from other statistical software. Readar is a great package for reading from plain text files, and Excel is this. And we're going to talk about Google documents in a bit as well. So what I'm going to do is I'm going to quickly scan through to see if I can find some themes in some of the questions, and then try to carry on a little bit. And then so that we can do a little bit of a Git demo as well, and then come back to questions again. Oh, relative file paths. This is actually a really good question. So, so let's talk about relative file paths. So the biggest thing you can take away from this talk, it's the smallest improvement you can have to your workflow is if you currently don't use RStudio projects, but you use RStudio already, you should use the project. So remember, I started my work by creating a project, which will then set the working directory to my basically project directory. And you can see that I am in that project because I can see it on the top right corner here. Now let's go ahead and do something in terms of relative paths. Okay, what I'm going to do is I'm going to create a new folder here called manuscript. And I am going to move our Markdown document into my manuscript folder. Let's go ahead and delete these outputs. And then let's maybe move this into the manuscript folder as well. Okay. And let's go ahead and open this up and let's try to knit it again. Now I get an error. And the error is because it says the path does not exist. And why am I getting this error? Because the folder called data is not in the manuscript folder. So when we knit in our Markdown document, it considers the current working directory as where it lives. Now, if I was to go ahead and run this code here, though, in my console, you can see that it works. So why is the code working when I run it in my console, but it's not working when I knit my document? Because in my global environment, my working directory, and I can say kind of get working directory, is my demo folder, so my project folder. So this is a mismatch that very regularly happens, and that can be quite annoying to work through. And in fact, the recommended solution in the chat is the right one, the here package. So what the here package does is, so let's go ahead and load it. And it basically gives a character string that's basically going to be the path for the current working directory. And it gives you the full path. But the thing is, if I was to share this project with you and you don't have this folder in your desktop, but have it elsewhere, here would know and recalculate that path for you. So it's not like I'm hard coding this text string. I'm calculating that text string is really what it is. So what I would want to do here is, so you can see that the convention is always to add any packages you have in the top of your document. So you're honest about what the dependencies are in a way. For file paths, although I think you'll often see the here function being used like this. Oops, I'm sorry, because I think people just like saying here. So what this does is it says start with the current working directory and then find the data folder in it. So if I run it in my console, it works. And if I knit it, fingers crossed, it works as well. So this would be the recommended solution for working with file paths, not hard coding them. Do work with RStudio projects so that the root is always that main folder where your project is, and then use the here function to construct your file paths. Okay, So now let's go ahead and maybe move on a little bit, but I'll come back to these questions before we wrap things up as well. So one other thing I wanted to show here was, let's go ahead and add, why did we go back to the source editor? Let's go back to the visual editor. I don't know where I lost the thread and we got to the source editor. And let's do, let's go ahead and add an R chunk where I am going to create a summary statistics, okay? So what I want to do is find, let's say, the mean of each of the measurements, all right? I'm going to start by species. I'm going to start with the penguins data frame. I'm going to group by species. And then let's say that I want to actually calculate the means of some of the variables. So usually what I would do here is remind myself the names of the variables. They're still a little bit annoying to copy and paste from in this format. So I can say, let's cat them out, separated by line breaks. So that makes it a little bit easier to copy them. Okay. And we'll say we're going to summarize these. So something I like to do is I'm holding down Option and basically, and then dragging down my cursor so I can write on multiple lines, and I want to find the mean of all of these, and I happen to know they're NAs, so I'm going to say NARM true, and then put commas and just delete the last one. That's just like a really nice way of getting a bunch of things at once. So here's a table that I have. And a function that's handy, that's in the knitr package is called cable, that basically will turn this output into a nice table for us, okay? Let's go ahead and take a look. So here's what our table looks like, okay? The summarize function has this new warning. So let's just abide by its wishes and say, make that warning go away. And then another thing I'm going to do is I'm going to name my chunk. And then you can imagine what I might want to do next is say table blah, 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 shows some summary statistics. So something I used to find quite annoying is to create these references. So now with the visual editor, they're actually a lot easier. So I can say ref, and then I can say I want a table. Because I didn't save my document. Sorry, let's go ahead and save it. Let's try this one more time. I'm going to go ahead and knit this real quick. It should give it to me as an option. So I wanted to demo that for you. Okay. Let's try one more time. I'm going to say ref. I don't know why it doesn't let me. Let's. I think I might know why. Okay, so right now this is not working, which is quite annoying. So one of the things that's happening here is that our Markdown output that we're working with. So HTML document is the default output. But what I'm going to do is I'm actually going to change my output to HTML document 2. And I will mention that this is something that's like a little bit, what do you call it? a little bit hacky, it feels like something too, from another package, from the Bookdown package. So this sort of functionality will ultimately be in our Markdown. It just currently is not. So if I go ahead and knit this now, I should be able to get my table numbering properly. Because the HTML document too from the Bookdown package actually has nice figure and table referencing. So now we can see something it doesn't like, but at least it's looking a lot more like an error I'm used to seeing. Let's see if it'll work now. I don't know why it's not working, because I've obviously tried this before I did this demo. We'll give it one more try, and then I'll try to figure it out while we're working on something else. I wonder what else I might be doing wrong. Sorry about that. Well, let's try a figure. I'll try one other thing in terms of this referencing, since this sort of stuff is actually helpful. So figure something shows some visualizations. Okay, so let's go ahead and add another R code chunk, and I will call this maybe many figures. And then let's add a caption for it. We have lots of figures. All right. And I'm going to go ahead and copy and paste a few pieces of code for you. I'm going to create 3 plots and show them to you. And then we can talk a little bit about laying out our figures, since that tends to be another pain point in working with documents like this. So I have one figure that's basically my computer can't handle Zoom. There we go. So one figure that is a visualization, like a scatter plot like this, another slightly different figure, and another slightly different figure. Okay, so I have these 3 figures, and I want to lay these out in the same 3 plots that I want to lay out in the same figure. A package that I would strongly recommend for doing this is the patchwork package. And I think there was a new CRAN release of it just yesterday or something, but it's an incredibly useful figure for working with, incredibly useful package for working with ggplot. And what it allows you to do is it basically allows you to do things like just put these figures together simply by using notation like this. So this should actually place our figures all next to each other in our Markdown document. So let's go ahead and show that real quick. So we see a bunch of stuff. We're going to correct these, but you can see that this basically places our figures together. But obviously, this is not a good look. So I'll talk about a few things that are useful for structuring figures in your documents. One of the things that you might want to pay attention to is your figure sizing. So I like to have an R chunk that basically has some options set for globally for my document. I'll call this chunk options or something. And I usually add include false for this because I know that I never want to show this sort of code in my output. But what this does by default is for all of our code, hide the code, hide the messages. The output width for the figures should be 80%. The figure width should be 6. And the aspect ratio for your figures, that's the golden ratio. So that's the height to width ratio. And then increase the DPI of your figures as well, especially if you're looking at them on the screen. So let's go ahead and give this a try to see what that does for us. I really think that Zoom is somehow slowing down my computer right now. I don't really know. Okay, so now we've gotten rid of our our code, and we have a different aspect ratio. But what I might want to do for this particular figure is I want to lay them out a little bit more nicely. So I wanted to highlight for you a little bit of the capabilities of the patchwork package, and then I'll let you play around with really what you need. But a few things that you can do is what I'm going to do is I'm going to place the first two plots next to each other and then make the other one kind of underneath them. I will add some annotation. So let's tag the levels in like capital letters so that my plots can be labeled A, B, and C. That usually helps with captions. I can have a title, maybe some title, a subtitle, and then maybe even a caption. And then what I'm going to do is you can see that the legends are repeated, which is kind of annoying when you have a figure like this. So I'll say that just collect all the guides and actually put them at the bottom. So legend position should be bottom. So let's go ahead and knit this to see what we get. So we are seeing basically our figure looks a lot better now. Now, a few things that I might want to do here is potentially kind of change up the aspect ratio for this particular figure. Maybe turn off those warnings there. We're just getting those warnings because some of the penguins don't have measurements. And then another thing I'm going to do is, I think that's probably good enough. Okay, so that's what we have here. And we basically have our figures all in one place. You can imagine writing a caption that refers to plots A, B, and C separately. So the patchwork package works really nicely with ggplot2 figures. But I believe other plots as well. So it doesn't have to be ggplot2, but it works especially nicely with those for having a layout like this for your figure. So I would strongly recommend it. And I'm going to give this one more try for referencing. So we can see that I can actually pick my figure reference. And I have a feeling I know what happened here. So let's go ahead and try that. Wonder if this was the reason why earlier on, because I didn't have a caption, that I couldn't actually select this. Yeah, so it needs a caption for the referencing to work properly. And that was the reason why it wasn't working before. You'll notice some peculiarities about our Markdown where we have captions work differently for tables versus figures, and that's just a peculiarity we kind of have to live with at this point, but otherwise things work pretty nicely in this ecosystem. So we can now see that actually our figures and tables are numbered as well, and they're numbered separately in terms of the count. So you can use all of this for equation numbering and whatnot too. So I'm going to move on to another part of the demo, but at the same time, what I'd like to do is put something in the chat so that we can come back to it in a second. So I'm going to put a very brief Google form on the chat. 3 questions, nothing personal, not collecting personal data, but note that the data will be publicly available. So I'm not asking anything, but I've made the sheet publicly available so we can go through the demo. If you want to answer those 3 questions, you can, I'll just show you how to pull that data in directly. But before I go to that, I'd like to go back to some resources. So let me go back and share actually my, there we go. So I'll give the link to the slides at the end again, but here's basically some documentation about our Markdown and then specifically about the visual editor that will be useful if you're going to be using this ecosystem. So the next bit on our, it still says that. I just, this sort of stuff kills my desire. How about this? Is that still the editable form? Great. I don't know why. It's like this super sticky thing that I seem to not be able to get rid of. Okay, how about let's take like a 1 minute break or 2 minute break. I'm gonna give this a try, but if it doesn't happen, I'm gonna move on because the last thing I want is battling Google right now. Let's take a couple minute break. Feel free to go get a tea or something. I thought we tested it right before the session, but it looks like we didn't test it exactly properly, right? Okay, if people just
it seems to work for some people, but not all of them.
That would be ideal. Oh, great. Now you guys are editing my Google form? That's not very nice. Okay, well, how about this? I will create a new Google form from my personal Gmail address that I don't think will have this issue. And we won't have to, and I will just delete the other form later. Not really sure if this is the best use of our time, but oh well. I think I'll just add maybe only one question in this new form, just so that can help us structure the rest of what we'll do. What about this? Does that form work? Okay, good. So let's go ahead and get some answers in there. All right, I'm going to give you just one more second to get the answers in. Yeah, there's only one question. I only had time to write one question. Sorry. Couldn't actually replicate the whole thing. Okay, so I will go ahead and maybe close the form now. Not accepting responses anymore on, let's see. Okay, we'll come back to that in a second. So we'll let those results stay there for a second and we'll come back to that. I don't know why I thought I could do a live demo. It's unnecessarily ambitious about that. So let's talk a little bit about using version control then. I'll go back to my slides. Okay, so use version control, maybe easier said than done, but we're going to take a look. So we have this R Markdown document that we saw under the hood is a plain text file, right? And what we want to do is we want to track our changes using Git, and we want to host our projects on GitHub. Git is not the only version control system out there, and GitHub is not the only web hosting system for our is not the only kind of web hosting platform for files tracked with Git, but these are probably the most commonly used ones in both academia, I believe, and in industry as well. There are really two Git workflows we can think of. One of them is the GitHub first workflow, and the other one is the local first workflow. So in the GitHub first workflow, what we do is, you're kind of in a GitHub mindset. And if you're starting a new project, you create a new repository on GitHub, you grab its URL, you clone it using RStudio, you make some changes locally, and you commit and push your files back to GitHub and confirm that your changes have propagated to GitHub. In the interest of time, what I'm going to do is I'm going to show you the other approach since we already have something local, but I will link to other resources for reading through the first approach as well, which to be honest, I think tends to be the more commonly used approach for me. So what about this? I've been working on a project for a while, and now I'm realizing that I should have been tracking it with Git. So how do I go about actually doing this? Step one, if you don't yet have it, you should create an RStudio project from an existing directory if an rproj file doesn't already exist. In our case, the demo project that we've been working with, we already have this, so I don't need to worry about that. And then I'm going to use functions from a package called useThis. And so what I'll do now is to kind of walk you through those and demo this idea of starting to do a Git tracking for this project that we've been working on, and then actually create a Git repository with that. So let me stop sharing my Keynote and go back to sharing my screen. All right. So we have a functional document here in a folder and our RStudio project. And what I'm going to do is I am going to load the useThis package. And note that I am not typing these things in my our Markdown document, but just in the console, and say that I want to track this project using Git now. And I can use the default initial commit is going to be, the message is going to be initial commit. So I'll just let that be. So let's see what it says. It basically is telling me that it's setting my active project to this one demo. That's great. Adding the files that I have here and asking, should I actually commit these? So I'll talk about the git ignore in a second, which is basically this third line. but it's saying, are you ready to commit all of these files? So this is a good time to think about, did I have anything here that I don't want to publicly share with the world? And you can, use private repositories too, of course, but it's a good time to think, to say either yes or no. I'm going to say yes, that's okay. And then it says that it wants to actually restart the RStudio, and I'll say, I agree. So that should restart my RStudio window. And now I have basically a Git tracked project. So we can see that I now have a new tab here called Git. And if I actually make changes to my document, right, that's actually going to show up here. So I have an R Markdown document that I've made changes to. Chances are what I want to do is I want to knit this document so that actually my changes propagate to the output as well. And I want to commit and push them together. So what we mean by a commit is, think of it as a snapshot in time that you are deliberately choosing to make a record of. This is not every single change you make to your document. It's also not full days of work either. So think about, as much as possible, what might be some ways that you go back and take a look at your history to see like meaningful changes to your document. And then I'm going to click on the diff window here, which basically shows me the changes in my R Markdown document. And the HTML document changes are a bit large, but if you actually want to see them, you can. The thing is, it's just showing us HTML code that's not that useful. So I'm going to go ahead and select both of these and say, I want to commit these files. So I'm staging them, as you can see. Made a change. And let's go ahead and commit it. Now that's it. Now I have made a commit, but where is this supposed to go? Currently, this Git repository does not have a representation on GitHub right now, and that's why this push button is not highlighted. So now what we can do is actually say, I want to use GitHub. And let me first show you the help file for this, because what it will actually do is say, if you have a GitHub organization you want to create the repo in, you could add that here. If you want this repository to be private, you could add that there. But otherwise, it's basically going to take your project and create a repository for you with the same name as the name of your RStudio project. Okay, so currently it is actually doing this for me, and let me go ahead and show you what this looks like in my browser window. Here we go. So I actually have a repository on GitHub, and if anybody is interested, since it's a public repository, I'm going to go ahead and put the link in the chat if you want to take a look at it. You can see the 2 commits I made so far on GitHub. And if we were collaborating with each other, you could be actually making edits to this repository as well, and I could be pulling your changes. Now, this might all feel a little too magical. How did it know who I am and to create this repository for me? So what I'll do in a second is give you some links to some of the setup options for use this that you can set up for yourself so that it will basically use that for you. You can set it up in your R profile, along with and also set up some keys for yourself through GitHub. But use this package really makes this incredibly easy. I will say this now, and I will say this one more time in a second. If you are going to be use this, I do strongly recommend downloading the development version. So that would be downloading it from installing it from GitHub, because the newest version actually has cleaned up so many of the hurdles that can be difficult about setting up your work, your authentication with Git and GitHub. Otherwise, wait a month or so, I think, and for the Crayon release, if you don't want to use a development, but I wouldn't use the previous version of it if you're completely new to it, because something a lot easier is about to come down the pipeline. So, so there is an alternative route for GitLab, but it is not the use this. The use Git would still work, obviously, but let's take a look to see. So I'll go to the use this website. So I'm not seeing a use GitLab function. So use Git would still work because that's about your local Git repository, but I'm not seeing a use GitLab function. This doesn't mean there isn't another package out there that might do that. And I know that at some point use this was trying to support other kind of Git web hosting services as well, but currently it seems like this creating the repo would be from there, but everything else would work. So you could try the other approach of creating your project there first and then starting that way. Okay, so let me try to do something one more time. Don't know why. Okay. All right. So let's go ahead and do this. I am going to, we have like 15 minutes or so. So I want to make sure that we talk about something that's of interest to you. And I want to make sure that I can show you one other way of pulling in data into R. So what we're going to use now is the Google Sheets package. So let me go ahead and enter an R code chunk. And I'll go ahead and paste this here. So this is a publicly readable version of the data from the survey that you all have just participated in. So let me show you here. And what I've done is, so you don't necessarily need to make this public for it to work, but I'm making the responses public just so you can see it as well. So the code would work for you as well. So here's what I have. I can actually read this sheet directly from, let's go ahead and load the package, Google Sheets 4, and I can read this package directly from Google Sheets using the read sheet function. And it will ask you to authenticate. So I'm going to go ahead and do that. So I can see that 147 people responded to the survey, and we can see the survey results like this. I'm going to change the names of these variables. Something I find quite irritating about Google Forms is that it gives the entire like question there, so it becomes an unusable name for your variables. And then let's just go ahead and make a bar plot to see what people want to see next. We restarted R, remember, that's why. So it looks like people want to see the articles package. Okay, so here's an example of reading in data directly from Google Sheets. So if your data lives in Google Sheets, you can use the Google Sheets 4 package. And I will say that not only can you read in data, but you can write data as well. So what I'm going to do is I am going to show you a very quick demo of the Google or from articles. And in order to do that, let me go ahead and for those of you who might be wondering, the link I'll give you at the end will lead to kind of a record of all of this as well. So I know that I'm going through certain things fast. So let's go ahead and take a look at this example. So here is the articles package. I have a manuscript and I'm going to write out to PDF this time. And let me go ahead and turn on the visual editor for this as well, just so we can see it like that. And I'm going to go ahead and knit this and then talk through a couple of the features of this package. And then we'll do a little bit more Q&A before we wrap things up. So here it is. I have a manuscript, and you can see that I have a few options in my YAML. One of them is my editor options. I personally like using sentence wrapping, where in my source code, there's a line break after each sentence. So when you look at diffs on GitHub, you can see changes really easily that way. So the visual editor can automatically do that for you. The canonical option is basically for if you have a collaborator who's also using our Markdown but is not using the visual editor, making sure that your source codes match. There's no mismatch between the two. I have some references here, but importantly, my output is not just a PDF document, but it uses the articles package, and I happen to use the ASA article format because that's what I had used for the last paper I submitted. So I figured I'd give that as an example. There are other formats there. And I'll talk about this in header tech in a second. So you can see here that the format basically follows the format required for the journal. I can list my authors like this. It marks the corresponding author if you want. You can have references. You can have our output, and the references I've added using the same citation option like I did earlier, except this time it's not inline reference, but I've put it in brackets so that it actually shows up in parentheses here in my reference. Okay, now let me show you one quick thing about what this this header.tech file is about. In here, I have two things. One of them is about one of my pet peeves. If you've ever written with LaTeX, it by default puts those really annoying green boxes around your references. It drives me up the wall. So you can actually change the color of those. So I always have some tech code for doing that. The other thing is about blinding. So the articles package will allow you to blind things. So let me go ahead and set this to 1. And then let's go ahead and knit the document one more time. So usually when you're doing a submission, you're going to want to blind, probably, depending on where you're submitting, I suppose. You might need to blind it. So it will take care of the author blinding for you. Now, another thing that might happen, though, is you might need to blind some other things. So, for example, I'm saying here's an intro for a study done at Edinburgh University, but maybe for the blinded version, I need to actually cover up that Edinburgh University, right? So one thing I like to do is to write some custom tech. So I usually create a copy of this header and then rename it as blind. So you can see that I've created a new LaTeX function called, or command called school. In the non-blinded version, that actually spells out Edinburgh University. In the blinded version, that spells out just school, and then it's formatted like verbatim tech. So let's go ahead and change this, what's being loaded here on top, to blind, and let's go ahead and knit it. And you can now see that my article has been blinded. So this is how I tend to take care of any sort of in-text blinding. And it's a really, you do need to know like a little bit of LaTeX, but I'm personally not a pro at writing LaTeX functions. If you just know the new command, that will allow you to do that. So if you have this sort of a paradigm that's already working for you in your LaTeX documents, you can actually have it work in your R Markdown documents as well. All right, so what I'm going to do is I'm going to dive back into the Q&A at this point, I think. Let me see. Let me quickly see what else I had. I might actually, what I'll do is I will change the slides. So I have in my slides a few things about what the history looks like and whatnot in RStudio. So I'll go over that. And this is one thing I'm going to skip, making pull requests, but maybe another time. But here are some resources for working with Git. Probably the definitive source for working with Git and R is Jenny Bryan's Happy Git with R. It really has step-by-step instructions. And another thing is the source of that magic in terms of how did I create my GitHub repository without authenticating. In the use this package in the setup article, it basically walks you through all the steps, and it has a bunch of helper functions for doing that. For automating your process, we've talked about having these scripts. Simply numbering your scripts and having an additional script that sources them is one very cheap way of automating your process, perhaps. And a slightly more expanded way would be something like using make. I wouldn't say that the what you need to learn for using make is necessarily I think it has a very steep learning curve, and I'm no pro at it, but Carl Broman has a great introduction to it. So if that's the route you want to go for automating some of your work, I would strongly recommend that. And there are a couple other approaches out there as well that you might consider. And finally, sharing your computing environment. So I think Docker gets talked about a lot here. You can basically encapsulate your computing environment. Another, I think, slightly user-friendly way would be Binder, which you can actually add onto your GitHub repositories. So it encapsulates the computing environment using some config files. So others can actually just kind of find themselves in your computing environment. And then perhaps the last one is, I think this is more like it's easier to set up, not necessarily the most principled way potentially going forward, but RStudio Cloud is also one option, and it might be the easiest option for collaborating with your collaborating with your collaborators. Just like today, you could literally set up an RStudio project that you share with them, and both of you could be computing in the same environment. And if you're and Google Colab is another option for that if you're more in perhaps the Jupyter ecosystem. So here are the 8 kind of principles that we talked about. I would strongly recommend this paper, Good Enough Practices in Scientific Computing. And what I like about it is that it's not best practices, it's good enough practices. And it's very honest about what might be kind of doable tasks that you could start doing today, basically. And here's the last slide. So I'll leave this here while I am working through the questions. This will take you to GitHub Pages landing page, which basically is serving the repository that has all of the information that I've worked through in this workshop. One thing I will change in that repository right after the workshop is the link to that Google Sheets, since we changed the form. I'll change that so that if you want to reproduce my code later, you can actually have access to the same data that we collected. So I'll make that push afterwards, but you can get to the slides, which will have the references to everything I referred to along the way. And you can also get to kind of some of the code for the other examples we didn't get to as well. All right, so let me go back to some of the questions. I feel like we were at, so for versioning, I would recommend between Renv and Packrat. I would just recommend Renv right now. So RNV or Renv, I'm not sure. So these are 2 packages for kind of keeping track of what package versions are needed in your like projects or repositories. And I would definitely say that the RMV package, which is newer, is the way to go. Let's see. So RMD to Word workflows, redoc. Yeah, I think that's what I was thinking about earlier. Let's see. What is the equivalent on Windows of the options tab to enter the same text into R Markdown? I have no idea. I'm sorry. Oh, Shift Alt A. There we go. 1 second. Sorry about that. Let's see if there are other questions. Well, if there are other questions, feel free to put them in the chat. So Git for code version tracking is great, but not for package versions. How about tracking your exact environment? So we talked a little bit about tracking the environment with things like Binder and Docker as the actual environment, or using RenV in terms of keeping track of package versions. That's what I would recommend doing. Right. Maybe that's it for now. Right, and we're like almost on time. Okay, oh, here's one question. My code is not working, but I'd like to share it with a friend. So you can just share, I suppose. So, oh, there are two ways actually. You can knit non-working code. What you would do is, as an R Markdown option, like we did warning false and stuff, you would just do error equals true. So it would actually print out the error for you. The other option is you can just share the R Markdown document. It doesn't have to be knittable. They can kind of look at the code. And then the third option I would say is the reprex package is incredibly helpful for generating helping you generate a minimum working example of the code that's not working. And you might actually solve your problem along the way, but otherwise it will basically create a snippet of, it will help you create a snippet of code that you can easily share with others. All right. Well, thanks to everybody. I hope you found it useful. And the link to the slides should be at the bit.ly link that's in the shared screen right now.
Yeah, and maybe you can also say that, so the recording, we will make it available. So we'll probably send an email to everyone with the link. And then we can also include the link that you just shared on your screen so that everyone has access to the files. And yeah, maybe we can just do a round of applause. So now it's just me and Jessie clapping.
Exercise.
And I can, yeah, I mean, you can see in the chat box, I think everyone is really amazed, and I think it was a brilliant presentation, and everyone really learned a lot. So yeah, thanks again for doing this workshop, and also for sharing all your slides and all your resources and making it so entertaining. That was really great.
Wonderful. Thank you very much. Thanks for having me.